Hello, welcome back to another video on Node.js. So here I'm going again, as I did in the last video, a quick recap of what is socket, right? And we're going to learn a very exciting topic and one of the fundamental of the internet. So imagine that you're gonna build a chat application, right? So with all the things that we already know, using HTTP, we can send a message using a post request and read all the message from using a get request from the server. So question is, when do we know, or how do we know specifically, how do we know when is the right time to fetch data? Data that is outside of our control, data that we didn't create. In the case of this chat application, someone else actually created that, your friend, for example, or data that might be in their own life cycle. So we usually deal with this kind of situation with a very quite effective approach, actually, and quite effectively and efficient, quite effectively. We often deal with this kind of situation quite effectively, actually, using polling, which is send a request so often in a period of time, and when that time has passed, send another get request in a loop extension. So this, for example, when you look at a pseudocode on JavaScript, that using the set interval to send that request, you set as 500 millisecond delay, which the issue with this approach is we're going to add that 500 millisecond delay for all updates first. Uh, and for example, for a chat application, this might be okay. But what about the real stuff? So like self-driving cars or trading or games, data that is not only outside of our control, but it might be in their own life cycle. But in any case, going back here of setting and know how to do this, right? Especially for a chat application. So this is a okay approach, but even though, think about this. Right now we're sending 2 requests per second and 120 requests per minute. And this is just for one single user. So imagine that you have 10,000 users. So now you have a scalability problem, or you need a very powerful server, or a different approach. That's where sockets come to the rescue. And to understand what socket is, first I look at the definition of socket from Merriam-Webster. That is an opening or a hole for for a holder for something. And in the context of networks, so this, for example, if you look for real life examples first, such as um, electric bulb socket, this is a holder, okay, or the eye socket, which is an opening, okay. But in this context here uh, of data sockets, they are an opening, much like your eye sockets. So they are an opening in a computer system. A computer is a programmable machine that performs arithmetic and logic operations automatically. And a system, computer system, is a computer, is a machine made of hardware, software. The main OS is the main software is the OS, and use peripheral. So in the case of desktop, you have this monitor, keyboard, mouse, uh, speaker, but in laptops, everything is come built in. So that's a great approach. Now, the thing here is this data socket, which is an opening in this computer system, much like your eye, in which you connect to send and receive data. So it's a holder of this type of connections, much like the electric bulb socket, all right? It's a holder for this type of connection in a computer network or in a series of computers sharing resource located on or provided by a network node. So this computer system, something that we'll talk about that later, in a real life example. So when we mention computer networks, so we can think of them as much like citizens in a state or in a last province, wherever you live, or whatever geopolitical organization they use in your country. But the thing here is that you can think computers as person, okay? Just for the sake of the example, again, this is just an example. Just to understand this analogy from the real life world example to a more abstract one, such as the computer network. So, if you think that each one of the people that live in that particular states are a humans, all right, and you may think of them as computers, all right, that after all, humans also exchange knowledge, love, insults, fluids, music, you name it, all right? So this exchange that happened here with humans is the same exchange or sharing resource in the computers. So because computers or citizens can live in a particular and specific geographical location, much like these computer networks, these uh, systems, these machines. In the context of computer network, when we talk about that, after all, it's a set of computers that share resource, much like humans does, that share resource located on or provided by network nodes. So these network nodes either is a redistribution point, such as the BGP, which is the broadcasting. BGP is the border gateway protocol, and what it does is to translate, share routing data between different autonomous systems. And thing is where, and this is where things getting interesting. So when we talk about autonomous systems in the context of computer networks, we mean is an interconnected network, aka a series of computers interconnected with another series of computers that operate under a single admin domain, meaning under Google. And because each member of this network is a computer, we can make some analogy in the real life world, like states, for example, or countries, right? So we can think of each one of those states are autonomous systems, right? So when they took or when they make decisions based on their own laws and their culture, blah blah blah. But here, uh, they're going to share resource based on a particular service. For example, in the case of Google, all right, they have a particular network of computers that offer Google Maps, to the internet. All right, so you have Google Maps to the internet, or the Office suite, right? We will keep YouTube as well. So all of this autonomous systems, right? All of this interconnected network that operate under a single admin domain, Google, much like the people that live in different states, right? And they operate or they are ruled, they're governed by the law of a particular country. So this analogy is something important because it can bring some light to anyone, especially that are new to this field or some tech savvy that wants to improve their own communication skill. And that's the funny thing, that's the interesting part, to explain that to non-tech savvy. So once I know this, right, and that the computer networks can be either a redistribution point, is a router, for example, the BTP, the border gateway protocol, that share exchange or the chain that exchange routing data across these different autonomous systems. Okay, uh, and it also can be a communication endpoint. So an address that identifies that communication entity, such as an application, a server, service, such as a computer, a mobile, firewall, gateway, uh, mm, you name it. Okay, so that's something very very important and interesting to mention, right? Computer servers, routers, switch, firewall, gateways, mobile device. That's something important to be able to communicate or articulate to others because this is one of the bare bones, especially if you're going to talk to others or if you're going to not only teach but if you want to provide value to a particular client. Okay. Mhm. If you're going to provide value to a particular client. So that might be feasible. That works. That might work for you. Okay. So with this, with that understanding, okay, that's when I look now at the basic building block of the internet, okay, and how this communication is what the internet is based on, okay. So you have now this IP socket, which is the basic building block, and on top of that you have is the datagram socket where low latency is more important, TCP when reliability is more important, and it's our connection based, meaning that before you send a message you need to connect, before you send or receive a message you need to connect, and it's also uh, reliable because you know when a message that you send is received. So on top of the TCP connection, we have is the WebSockets and the HTTP. Okay, so so the cool part of this, okay, is WebSockets is an important feature concept that back developers and web developers must know, because the internet consists of billions and billions of these IP sockets, right? And on top of that, we have is the WebSocket, which is a JavaScript feature that allow two-way communication between the user browser and the server. Okay. So this is where the real power is. And when you compare socket versus HTTP polling, with after all, polling is using the HTTP protocol to mimic this two-way communication, whereas with sockets, we already have an open channel between the browser and the server that allow real-time communications. And by having this channel open, sockets allow to have this two-way ongoing conversation to, to happen. So I look at implementation of that, which is something that I'm quite familiar. But the thing here is that this is something revolutionary, because now we can know when to fetch data, because the server is now responsible to keep the client up to date, and the client doesn't need to guess when to fetch data. So recognize the WebSocket allow that it allows these two-way communication data binding, or this two-way communication between the user's browser and the server. And the most common use for that allows you to bring value to the company on the company needs. So with WebSockets, uh, now it changed the way how, or it changed the workflow chat model. Okay, so like HTTP, where you have several implementation of how to get the data from the server in libraries like Axios or NoFetch, WebSockets can have different implementations. So we have is the WebSocket from Node.js library, the WS, okay, that it has its own particular way of listen or send message, and it based on the event emitter model, right? The only difference, or the only problem, is that it doesn't work on the browser. So you need to rely on the native WebSocket for that. So if you look at this, so we have is these two different interface, especially for listen, uh, new connections, or listen or events as well. So we have on the server using the event emitter interface, such as on or send, and on the browser we have is the add event listener for that. So if you want to put, or if you just want to rely purely on WebSocket object, if a browser doesn't support that, we're not able to use it. That's another uh, uh, sad things about this. This is very sad about this. So, however, there is a top-level convenient library that works in both ends, the client and the server, called Socket.io, and provide fallback in case the browser doesn't support WebSocket. And this is something crucial to know, because okay, Socket.io can provide fallback in case the browser doesn't support that. In case the browser doesn't support WebSocket. So Socket.io is an extremely popular library that make it easy to use, using the same interface, while providing while providing uh, fallback while providing uh, browser fallbacks. Okay, so this is just that marks the end of the explanation about WebSocket. Okay, so yeah, so WebSockets are very powerful because now the server is responsible to keep the client up to date, and the client doesn't need to uh, guess when to fetch data, all right? Which is great. This architecture is based, or this type of architecture is based on centralized communication, all right? But for decentralized communication, might not be feasible because again, you have this client and server architecture. But in any case, we can use the WebSocket is relying on the WS native package that allows to use the WebSocket that is based on the event emitter where we cast is on or send, all right? And the only trade-off is that that package it only works on the server. So if you want to use WebSocket on the browser, you must rely on the native object. But if the browser doesn't support that feature, then you cannot set that two-way communication. So there's this top level, very convenient package that allow this uh, these two communication, and it works in both ends, the client and the server, and provide fallbacks from them. So this is a very popular library. It's extremely popular library and make it easy to use the same interface. So we don't have to worry about we need to use this on the server, the use, the on or send, and the client will need to worry about the use the dot act event listener. Okay. So Socket.io is a convenient wrapper of using the same interface while providing browser fallback. Okay. So this introduction to Socket.io from Day. Okay. The introduction to Socket.io is why is this so widely used? Okay. Why is this so widely used? Allow RTC, bidirectional and event-based communications that works on every platform or device, so we don't have to worry about compatibility issues. That's the reason why we use Socket.io. Okay, so it is widely used, allow RTC, bidirectional and event-based communication that works on every platform or device, so we don't have to worry about compatibility issues. Something that is very crucial, especially for large enterprise scale applications, right? Socket.io is used by professionals like Microsoft, Office, and Trello. But again, the Socket.io here is widely used, allow RTC real-time communications, bidirectional and event-based communication that works on every platform. Yeah, that works on every platform or device. So we don't have to worry about compatibility issues. Now, taking a closer look of the Socket.io documentation, by having a client and a server using the same API, we don't have to juggle in between different APIs with two different set of functionality and can stay focused on building our app node or app code. It allows to save brain power for creating new exciting features as opposed with the and with you, as opposed to hunting bugs and worry about compatibility. We can still have bugs, but if we can minimize 10 to 20% of them, we can save a lot of time. There's another perk which is important when building large-scale production applications, and that is fallbacks. And that is fallbacks. So, alright. Again, this introduction to Socket.io, well, why is this so widely used? Allows RTC, bidirectional, and an event-based communication that works on every platform or device, so that you don't have to worry about compatibility issues. And websites or professionals like Microsoft Office and Trello use them behind the scenes. So with Socket.io, we have is the uh, the architecture of the Socket.io is we have the client and server. So by having the client and the server using the same API, we don't have to juggling between different APIs with two different set of functionality. We can stay focused on building our app code. It allows to save brain power for creating new exciting features as opposed to hunting down or as opposed to hunting bugs and worry about compatibility. Again, you can still, again, you will still have bugs, but if you can minimize uh, 10 to 20% of them, we can save a lot of them. All right. There is one another perk which is important when building large-scale production application, and that is the fallbacks. So now that I look at this, and I am able to articulate, mention, to describe uh, the socket.io, an example of the socket.io, what a socket mean, um, yeah, what a socket mean, what are computer networks, what are computer systems, and the basic building block of the internet, which is the IP socket diagrams, but you also have diagram socket, TCP sockets, HTTP, and um, WebSocket. Okay, and then I look at comparing the socket versus polling and how using WebSockets allow us to create this two-way communication between the user browser and the server, and how using is some of the native WebSocket package is not ideal because it doesn't work in both ends. And also, you cannot guarantee uh, to, or it is hard. You have to implement your own solutions when a particular browser doesn't support WebSocket, right? So in that case, there is a top level, very convenient package that allows us to use WebSockets in both ends, the client and the server. So we don't need to worry about juggling between different APIs set with different capabilities. Uh, so we can focus on writing our app code. So we can save brain power in, so we can save brain power instead of uh, hunting bugs or errors. Again, you will still have to you'll still have bugs, but if you can minimize them by 10 to 20%, it can save you a lot. Okay, so that's the reason why I'm looking at the socket.io, which it allows this real-time communication, two-way communication, and event-driven uh, base API that works on any platform. Yeah, so that works on any platform. So without having to worry about compatibility issues. And that's what we are here. So socket this introduction to socket.
On top of those standard, just by using one API, we'll be saving ourselves a lot of time. We'll be learning a lot more about these two components of the Socket.io library very shortly, as well as the excellent high-level APIs that it provides us. But there's one other perk that I wanted to bring up, which is important when building large production scale applications, and that is the fallbacks. When we start up our chat application on the client side, the Socket.io library will attempt to establish a WebSocket connection between the server and the client. And if the client side, the fallbacks. When we start up our
Which is the fallback. Go to the fallback. Go to the fallback. This is fallback.
our chat application on the client, large production scale applications, and that is the fallbacks. When we start up our chat application
When we start our chat app
on the client side,
on the client side, okay,
the Socket.io library will attempt to establish a WebSocket connection.
mm-hmm. the socket, the socket.io library will attempt to
Chat application on the client side, the Socket.io library will attempt to establish a
okay, will attempt to establish or set will attempt to establish a WebSocket connection.
WebSocket connection
A WebSocket connection
between the server and the client.
between the server and the client.
And if the client is one of the less than 3% of browsers that don't support WebSockets, Socket.io
And if the browser, if one of those less than 3% that doesn't doesn't support WebSocket, you can check that out here. Can I use it website, okay, and ask for that. Really using this plain JavaScript for that. It's blah blah blah. Can I use it? WebSocket. The WebSocket API. So it's like that. So it's 97%. So if you're using a Safari, for example, Firefox, or Opera, is still out there, or Android, which still are people using that. Opera or Safari on iOS. Google browser, unknown, is unknown. But most of the time, on the web or on the um, laptop or desktop, right? So they support that, right? And maybe incorrect. For subject API URL, send, close, protocol, ready state, binary type, extension, open event, close event, and fill event, right? And again, this is to attempt to establish an HTTP WebSocket connection. So let me put in here. This is support. No, this is support WebSocket. Right. So if one of those less than 3% doesn't support WebSocket,
Sticks to a form of polling. Is one of the less than 3% of browsers that don't support WebSockets, and the client. And if the client is one of the less than 3% of browsers that don't support WebSockets, Socket.io sticks to a form of polling.
okay, for WebSocket, Socket.io stick to form polling.
Similar to what we saw earlier. This way, you're guaranteed to
Mhm. This way, you are guaranteed.
have your application run on all devices.
Mhm. This way, you are guaranteed that your app works on all devices.
Very important in a corporate enterprise environment.
Very important in incorporate.
You're guaranteed to have your application run on all devices. Very important in a corporate enterprise environment.
Very important in corporate environment.
Now that we've sampled what Socket.io can provide for us, let's dig a little deeper at the implementation. I'll see you in the next one.
Okay. Now let's take a dive deep on the implementation. Oh, he mentioned another thing.
Now that we've sampled what Socket.io can provide for us, let's dig a little deeper.
Let's take a little deeper. Okay, let's take a little deeper on the implementation.
At the implementation.
Or at the implementation. Sorry. At the implementation.
I'll see you in the next one. To all the clients. We can see that we have the default emit function. Welcome back. We've seen that Socket.io is composed of two parts. A server library, which will integrate with the Node.js HTTP server.
Client server API.
and a JavaScript client-side library that loads on the browser side. These live in two separate GitHub repositories. We have Socket.io for the backend, and we have Socket.io client for the front end when we're using JavaScript. But even if we wanted to create a client in another language, say Java or C++, there are implementations of Socket.io which we could use to talk to our Node.js Socket.io server. So this is a very versatile library. There's even bindings for Dart and Swift. And if we scroll up here to the Learn section, we can see that there's a server API and a client API. So the functions that we'll be using aren't exactly the same. But this makes sense because, as we're about to see, the client and server need to support different sets of capabilities. They have different roles. Remember our chat example? With sockets, like with HTTP requests, on the client side, we always talk to the same server. We'll only ever send messages to that server. However, on the server side, sockets allow us to send messages to any one of the many clients that are connected. So say we had another client that connected to our server, that joined the chat room. The server would be responsible for sending any updates, any new messages to that new client, whether it be the original hello message or a message from any other client. So our server needs to be connected to and sending messages to multiple clients at the same time. This is different than the HTTP requests that we've already seen, where the server will always send a response to the client that made the corresponding request as a response to that request. With sockets, the server can decide when to send messages to the client. What does this difference mean for our socket API? It means that our server will need to support some additional functionality over the client. For example, by keeping track of the multiple clients that are connected to it, and by having the ability to send messages back and forth between these clients individually, or to broadcast messages to all of them at once. For example, when the server receives a new message, it needs to notify all of the clients of that new message by broadcasting it. The reason behind Socket.io's success is the excellent high-level API that it provides for both the server and the client. In the server API, as well as in the client API, it uses the Node event emitter pattern around which Node's core APIs are built. If we remember, with the event emitter pattern, every action that occurs in Node, like a connection being opened or a message being sent, every one of these actions can be represented as a named event, which can be emitted using this emit function. So for example, in our socket, we could call the exact same corresponding emit function on our socket, and this would send a message to the client connected on that socket. However, it's also common to want to broadcast a message to all clients. For example, when the server receives a new chat message. And there's this handy emit cheat sheet. If we go to the documentation page and go to the emit cheat sheet here, we can see all the different ways in which we can send a message or emit a message in Socket.io. Now, don't worry, we don't need to be familiar with all of these functions. Right now, let's take a look at the most common example, which is broadcasting messages to all the clients. We can see that we have the default emit function, where we name our event and then pass some data to it. That will be sent to a single client. We also have this socket.broadcast.emit function, which has a similar payload of a named event and some data. And we can see that this will send to all the clients except the sender. So all the clients except the one that is connected on this socket. We would use this, for example, in our chat. When we receive a message on this socket, we can then call socket.broadcast.emit and forward that message to all the clients except the one who originally sent it, because that client will already have that message. Now, in some cases, we'll want to send a message to all the connected clients, including the sender. For that, we have this io.emit function, where we send some data to all the clients that are connected to our socket server. If we compare this to the lower level WS package, which works just on the server, it actually has some usage examples where it implements this higher level functionality from the functions that it provides. So if we wanted to broadcast using the WS library, we can see that to broadcast to all clients, including the one we're currently receiving a message on, we would have to do several lines where we respond to a message and then go over a list of clients that are stored in our WebSocket server. And for each client, check if it's ready to receive data, and if so, send it the data that we just received. This would be one line in Socket.io. And we have a similar function here for broadcasting to all the clients except the one that we're receiving on. So similarly, we go over the list of clients, make sure that the client is ready, and check to make sure that the current client in our list is not the one that we're receiving on. Just with this simple example, we can see that Socket.io makes our life easier for the most common usages of WebSockets, while also allowing us to build reliable production scale applications, for example, by taking advantage of the fallbacks that we discussed earlier. All right, it's about time we got to some coding, don't you think? I'll see you in the next one. Welcome back. You're still here after all that theory. Let's finally get into our Pong game. We've looked in some depth at how we might build a chat application. This is a basic example where the text messages that users send, like hello or what's up, directly correspond to messages sent between the client and the server. But this is kind of boring. So let's apply what we've learned to instead make a multiplayer Pong game using sockets. In case you're not familiar with Pong, Pong was one of the first video games released in 1972 by a company called Atari on this massive upright gaming cabinet. And Pong was a 2D ping-pong themed video game where each player is represented by a paddle and you try to get this ball past your opponent, where one player's score is kept track of on the top right and the other player's score is on the top left. We're going to start with a recreation of this Pong game written purely in JavaScript on the HTML5 canvas with no additional frameworks. You can see here that we have our source code in HTML and JavaScript, as well as some style sheets. For now, let's load the HTML and notice our Pong game. Right now, it's a single-player game with a simple, what I like to call jittery AI that follows the ball and hits it back at a limited speed. And you can see that we move the paddle around with our mouse. If I go off the canvas, you can see the mouse moving here to the left. And the scores are kept track of in the middle. On top for the computer AI, and on the bottom for my paddle. So we're very similar to that classic Pong game, except we've flipped the orientation by 90 degrees. So now, instead of hitting the ball left to right and right to left, we're hitting the ball up and down. Otherwise, we're pretty faithful to the original. Now, this isn't a course on the HTML5 canvas or front-end JavaScript. So we won't go into detail about how to build these graphics, the AI, or the game logic for Pong. But we will do a brief overview right now. In case you do want to learn more about the steps to make this single-player version of Pong, take...
Oh, okay. In case you wanted to know about that, yeah.
Take a look at the Zero to Mastery JavaScript 20 Web Projects course by Jacinto and Andre. In that course, you do 20 varied projects using pure JavaScript, and one of those projects happens to be Pong over here. And the Pong game you build in the JavaScript projects course is nearly identical to the one we have in this course, with just a few tweaks. So let's get to the code. I'll see you in the next one.
Okay. So, that'll be all for this video. Take care. Bye-bye.